So look at the try it here is the bottom of page 254. Lesson 5.1 we're going to be talking about is on writing two-step equations. Our focus here in this lesson is going to be on writing equations. We know how to solve the equations. We've already learned about that, but right now we're just going to be setting up the equations that we could solve in order to find the answers. We'll talk about actually solving them again later. So if you look at the try it, Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments P. What equation represents the relationship between the cost of the laptop and Cole's payments? Alright, so if we think about this, if we come over to the side, the book has made a bar diagram for us here. So the bar diagram we can kind of look at and see what's happening. So the top part represents the total cost of the laptop, which is what? $335. $335, okay. And then there was a down payment, which is how much? $50. Okay. Now, some of you may not be familiar with that term down payment. A down payment is if, for instance, you can't afford to pay for the whole thing, or maybe you just don't want to use as much money. You want to save up some of your money just in case you need it for something else. You pay part of the price of something and then you pay the rest kind of later as you go. This is really common, more so besides buying a laptop, buying a vehicle, especially buying a house. That's a common thing to make a down payment because generally people haven't saved up the full amount that it costs to buy a car, or especially, like I said, to buy a house. All right, so then you can pay that over time. Actually, it's not as much for cars, but for a house you can actually do up to like 30 years that you can pay that house over. All right, look then besides the down payment, then you see all the letter P's here representing the different payments. Okay, and there are 6 of them because that's 6 different payments that were being made. Okay, what we can do then, we're going to translate that information into an equation here. So the cost, we could say, is equal to our down payment plus the number of payments times the monthly payment. So we have our down payment and then however many times we pay times how much we pay each time. Alright, that's kind of a general framework for us to get started here. Then we're going to translate this over into some numbers here. So the cost, we know the cost of the laptop was $335. We just said they made a down payment of $50. And then how many payments are they making?
6.
Okay, and how much are they paying each time?
50. 56.
P, good. Now, the book is using the multiplication symbol. We've kind of gone away from that a while back. So you can use parentheses there, or we can write it a different way we'll talk about in a minute. Okay? And again, this kind of goes back to that bar diagram. Hopefully from this you can now look at your bar diagram and see how that matches up. The 335 is the whole thing, and that's equaling the 50 plus the 6 payments. So rather than adding all those P's together, we could just say 6 times P. Okay? We can rewrite this slightly if you want to then. We could say 335 equals 50 plus 6P. And then that's kind of that assumed multiplication if the 6 and the P are right next to each other. So this would be an equation that we then could actually solve to figure out how much the payments were each time. Example 2, a baseball weighs 25.75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box W. So they're not just looking at the baseball and the bat here, they're actually comparing this with the weight of the box. So that actually, our equation then, we would be able to figure out what the weight of our box is. If we look at our picture over here, we can see about what's happening here. So we have a box that has 50 bats and it weighs W ounces. The baseballs are not in the box here, but just for comparison, one baseball weighs 5.25 ounces. Now, one thing they're not doing in the book here, they're not getting technical because technically the box has a little bit of weight to it. The book is not considering the weight of the box, all right? It's probably looks like cardboard here, so it's not like it's super heavy, but there would be some weight to the box as well that normally we would need to consider. But they're ignoring that because we've got enough other stuff going on here, I guess. All right? So this is not quite technically correct, but that's okay. All right, so we got the weight of the baseball, which is 5.25. It's equal to the weight of one bat minus the 25.75. Now the weight of one bat, we actually don't really know anything about that. We do know though that there are 50 bats in the box. So the book's saying the weight of the box is W. If we took that weight and divided it by 50, then that would be the weight of one bat, assuming we're not worrying about the weight of the box again. Okay, so total weight of the box divided by 50, that's one bat, minus the 25 and 75/100ths is equal to the weight of our baseball. So that would be an equation then that we could use, and again, technically, we would be using that equation to figure out what the total weight of that box is, not including the box itself, I guess. All right, so let's look at the try it. Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. So they want us to write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers. So a problem like this, if we draw a picture, might help us to visualize what's happening a little bit. So if this is our beginning of the race, here's Marcia, and she's run 4 kilometers. Not finished yet. Tamara says has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. So she's run further than Marcia. So we can just extend a little bit past where Marcia's at here. And she's 2.5 kilometers beyond where Marcia is. That's Tamara. So kind of like the bar diagrams the book has done with some of the problems, if we think about this, what they're telling us is that Tamara has completed 3/4 of the race. So again, she has a little bit to go yet. There's a little bit of the race she has not run yet. But if we think about it, this total distance that Tamara has gone represents 3/4 of the race. And also K is representing the total length of the race. So 3/4 of the race, there's that keyword indicating that we're going to be multiplying. So to represent how far Tamara's gone, that would be like 3/4 of K, or 3/4 times K. Now if you look at this, you can see the 3/4 K is actually equivalent to these other two pieces added together. So 3/4 K would be equal to 4 plus 2.5. And again, they're not asking us to actually solve the equation. We could do that, but at this point they're just asking us to write an equation that we could solve to figure out the length of the total length of the race.